Hello guys, welcome back to this YouTube channel. Today we shall be talking about analysis of truss. And in analyzing truss, there are two basic methods you can use, which include graphical and analytical method. In analytical method, we have section method and joint method. Whichever method you use among all these, you will arrive at approximately the same answer. For the sake of this problem, we shall be using joint method of analysis of truss. Now, let's get back to the problem. Looking at this figure, you see that this is 60 degrees, this is 60 degrees, therefore this place is 60 degrees, sum of angle in a triangle. So that makes this an equilateral triangle. And since it is equilateral triangle, it means that if a line is drawn from here, it will be exactly at half the distance of this 6 meter, which is 3 meter, 3 meter. So this is equilateral triangle, and therefore there is no need resolving the distance at which this force is going to act. But had it been is something like isosceles or scaling triangle, that means you're going to get the line at which this force will act, maybe using either Pythagoras rule, sine or cosine rule, whichever one that will give you the side you are looking for. Now, without much ado, let's get into the problem. So we can say let summation of moment about point A be equal to 0. And by so doing, let's say let's equate clockwise turning forces to anti-clockwise turning forces. Like we all know, moment is product of force and distance. So when we talk about this 2 kilonewton, you check the distance which it will make to get to point A. 3 kilonewton also, and all these forces. Now these 2 kilonewton and 3 kilonewton and even 1 kilonewton will move in a clockwise direction to point A, but VB will move in anti-clockwise direction. So by saying that clockwise moment equal to anti-clockwise, it means that this VB, which is anti-clockwise, will cover a distance of 12 meters, will be equal to all these other ones multiplied by the distance which they will make to reach this point A. So we have 2, which will cover a distance of 3, plus this 1 kilonewton, which will cover a distance of 6, then plus 3 kilonewton, which will cover a distance of from here to here, which is 9. We have that VB is equal to 39 all over 12, which is equal to 3.25 kilonewton. Now, to get the value of VA, we can take moment at point B, or rather we can say let upward force be equal to downward force. With that, we are doing summation of vertical forces to be equal to 0. So the forces that are coming down are these 2 kilonewton, 3 kilonewton, and 1 kilonewton. Then equate it to the one that is going up, which is VA plus VB. We have 6 is equal to, already we know VB to be 3.25, then plus VA. So our VA is equal to 6 minus 3.25, which is equal to 2.75 kilonewton. Now let's write the values. We got VA to be 2.75 kilonewton and VB to be 3.25 kilonewton. To get the nature of forces at all the members, we are going to redraw this figure. After redrawing the figure, we can assign different directions to all the members. But before then, let's label this. Remember, you can label anywhere. Then having done this, we can go ahead now to give directions. Assigning the direction to the members, you can decide to assign either compression or tension to any of the members. And you know, when you talk about compression, it's just the force trying to bring two things together. And what we're going to represent here is the internal force, which tries to oppose the compression. Likewise to tension. But for easier understanding, let's assign compression to all the members. In that case, if anyone comes out negative after calculation, we will know it is tension and not compression. So we are going to solve for all the joints to get the members. Solving, make sure you start with joint with not more than two unknowns. If you look at this joint, this member is unknown, this is unknown, this is unknown, and this is unknown. Therefore, you cannot start here. But if you look at this, you have unknown, unknown. Therefore, it has only two unknown. That's to joint B. So we can start with joint A. And in this joint A, what you have to do is to make a sketch of what you see around this joint A. If you look at joint A, you actually see that there's a force going this way. There's another one horizontal, and there's this vertical force. So that is what we'll try to replicate. Now, the angle here is 60. So you put down that. All these lines is just to indicate your vertical and horizontal line. And remember, this place is 2.75 kilonewton. Okay, let's say summation of vertical forces to be equal to 0. The vertical forces we have here is this 2.75. And for this force that is neither vertical nor horizontal, you are going to resolve it with the angle which it makes with this horizontal line. By so doing, you will have 2.75, which is pointing upwards. And if you resolve this FAC to appear vertically, the arrow is going to be pointing downward. So the one that is pointing upward should be equal to the one that is pointing downward. That is equal to FAC. Since you are talking about vertical resolution, you are going to multiply this with the sine of whichever angle it makes with horizontal line, which is sine 60. Therefore, our FAC is equal to 2.75 all over sine 60, and that will give us 3.18 kilonewton. It is positive, therefore this is compression. We shall also resolve the horizontal forces. Like we did in the vertical forces, any force here that is not on the horizontal line will be resolved, and it's going to be the force multiplied with the cos of whichever angle it makes with this horizontal line. And like you can see, this arrow is pointing towards this direction, and if this fs is resolved to appear horizontally, the arrow likewise will point towards that direction. So since the two arrows are pointing towards the same direction, you have FAC cos 60 then plus FAE is equal to 0 because there is no other force going in opposite direction. You already know the value of FAC to be 3.18. You have 3.18, then cos 60 plus FAE equal to 0. So FAE is equal to minus 1.59 kilonewton. This is negative, therefore it is tension. With this, we are done with this joint. Therefore, we can proceed to the next joint. Let's go with this joint C, because already we know this member. Therefore, we have two unknown left. So let's sketch what we'll see around this joint C. This is exactly what we have around this joint C. This vertical force, and there's a horizontal, and there's a vertical line at which it acts. And between these two lines is 60 degrees. Therefore, let's also extend this our horizontal line. So if here is 60 degrees, but this is equilateral, therefore this place is 30. And if this is 30 and this is a perpendicular line, therefore this place will be 60. Likewise this place. And this member is FCD, whereas this member is FCE. And this is FCA or FAC, whichever way you want to call it. Also, we'll go ahead to resolve the vertical resolution to be 0. Okay, therefore any force here that is neither in vertical line nor horizontal line will be resolved with the angle which they make with the horizontal line. To start with, we have FAC or FCA, whichever way you want to call it. Then sine the angle which it makes with the horizontal, which is 60, plus FCE sine 60. Remember, all these two forces, if you resolve them to appear vertically, they're going to be pointing upwards. But this 2 kilonewton is going to oppose the direction, which means the one that is going up should be equal to the one that is coming down. With this, we have FAC already to be 3.18, then sine 60 plus FCE sine 60 to be equal to 2. So FCE is equal to 2 minus 3.18 sine 60 all over sine 60, which will give us negative 0.87 kilonewton. So this is tension. Let's do the horizontal resolution. So the horizontal force here is FCD, and for all these ones that are neither vertical nor horizontal, we resolve them with the angle which they make with the horizontal line. By so doing, you are going to multiply all the forces with the cos of the angle which they make with this horizontal line. So if you resolve this force to appear horizontally, the arrow will be pointing towards this direction, whereas FCE will be pointing towards this direction. Therefore, these two forces that are pointing the same direction will be equal to the one pointing in the opposite direction. We have FAC cos 60 is equal to FCE cos 60 plus FCD. Already we know FAC to be 3.18, then cos 60 is equal to FCE, which is minus 0.87 cos 60 plus FCD. So we have that FCD is equal to 3.18 cos 60 plus 0.87 cos 60. Our FCD will be equal to 2.025 kilonewton. This is positive, so it's compression. With this, we are done with joint A. Joint C. Since we have known joint A, joint C, we can proceed to solve joint D. And after solving joint D, there will be no need solving joint E, since all the members from this joint E is connected to C, D, and the rest at B. So we must not really solve all the joints. 1, 2, 3, 4 will be able to give us all the members and the nature of the forces. Now let's draft out how joint D will look like. So at this joint D, we have something like this. And there's also an imaginary line here, and there's another one here also, and between this place is 60. Therefore this remaining side is 60, because this is perpendicular line and here is 30. This is 60 also, and this member is FCD or FDC, whichever way you prefer to call it. This is 3 kilonewton, This member is FDB or FBD, depending on how you wish to call it, and this is FDE. So with this, we can select the summation of vertical forces to be equal to 0. We have vertical force, and these other ones, you resolve them. And in resolving, we have 3 is equal to FDE sine 60 plus FDB sine 60. 3 is equal to sine 60 is 0.866 FDE plus 0.866 FDB. Call this equation 1. Also, in resolving horizontally, you have FDC plus FDE cos 60 is equal to FDB cos 60 degrees. And the FDC is 2.025 plus cos 60, which is 0.5 FDE, is equal to 0.5 FDB. Call this equation 2. Now, you can bring the equation 1 and 2 together and solve using either simultaneous equation method, or you can use matrix method, whichever one you prefer. Or rather, you may decide to just press the answer in the calculator and go ahead to write it the way you see it there. And maybe if you don't know how to solve this using calculator, you can check our previous video where we actually demonstrated how you can use calculator to solve different problems in mathematics. So in solving this, you are going to add that FDE is equal to minus 0.29. So since it is negative, that means it's tension. And FDB is equal to 3.67. It is positive, so it's compression. Now, with this, we have finished everything about joint D. Therefore, let's also talk about joint B. Since once we have joint B, we have gotten all the members. So let's sketch joint B. And don't forget, this place is 3.25 kilonewton, value of VB when we calculated. So there will be no need doing vertical resolution here, since the member you want to get is just this member. So and this member is a horizontal line, so let's resolve horizontally, and with that we are done with this problem. We have FBE plus FBD cos 60 degrees to be equal to 0, because two of them are moving in the same direction. And we have FBE is equal to minus FBD cos 60 degrees. Therefore, our FBE is equal to minus 1.88 kilonewton, and this is tension. So what we did here is that we substituted the value of FBD from what we solved, and remember FDB is same thing as FBD. Now we can summarize our results by drawing a table showing the members, the magnitude of the forces that we have calculated, and the nature of the forces. Don't forget, in the question we have 1, 2, 3, 4, 5, 6, 7 members, and that is why our serial number ranges from 1 to 7. Then for the members, let's look at this and draft all the members. We have member AC, we have AE, we have CE, we have CD, we have DE, and we have DB, And finally, we have this member BE. Okay, let's revisit what we calculated and know what the magnitude of the forces are. For member AC, we got 3.18, and we said it's compression. Then for member AE, we got minus 1.59. Remember, you're not going to write this minus here because there's no negative force. The minus only shows that the direction you assigned is opposite of what it should be. Then for CE, member CE, we have 0.87 and it is tension. Then for member CD, we have 2.025 and it's compression. Then for member DE, we have 0.29. We have 0.29 and it is tension. Then for DB, we have 3.67 and it's compression. And for this member BE, we have 1.88. So we have 1.88 and it is tension. So with this, I believe we have done justice to this problem. If you find it difficult with the resolution, you can visit our previous video. I will also drop the link in this video where we talked about corplanar forces. Thank you for watching this video. Make sure you subscribe to this YouTube channel. Since you know that subscription is free, please endeavor to do that. Thank you.